Hi everyone, my name is Cristian Yones and this is the workshop RoLa, a free and open source LoRaWAN operations and cybersecurity management platform. I'm a machine learning engineer at Argenis, a firm based in Argentine dedicated to software development and research. And in this workshop will also participate Matias Sequeira, a cybersecurity researcher who also worked on the development of RoLa. So in this workshop we will see how is the installation process of the free community edition of RoLa. We will learn how to create a custom configuration policy and how to connect RoLa to your LoRaWAN network. Then we will make an overview of the section of the system, and we will learn how to receive alerts when problems occur and identify weak keys and other vulnerabilities in your devices. We will learn how to generate an inventory of all your devices of your LoRaWAN network and get a 360 view of each one of them between other use cases. So let's start with the installation process. RoLa is pretty easy to install. It's done with only 2 commands and it only has 3 dependencies. You need to have installed Git, Docker and Docker Compose. Depending on your platform, the step to install each one of them may vary, but the 3 are available in Mac, Linux and Windows. In the case of Windows, which is my case, the easiest way to install all the requirements is inside WSL2, the Windows subsystem for Linux. Here I have a virtualized Ubuntu 2004 terminal. I have installed Git, Docker and Docker Compose. So the first step is to clone the main repository of the RoLa Community Edition. This is done with the command git clone and the URL of the repository. Then, with the Docker service running in the background, we get inside the project folder and execute Docker Compose app -d. The first time you run this command, Docker needs to download all images from Docker Hub, and therefore it will take a moment. I have all the images already installed, so it takes only a few seconds on my machine. There are other ways to run RoLa that are useful if you want to modify the source code, but we will not talk about them because they are a little more complicated and have more dependencies. If you are interested in contributing to this project, you have plenty of information about how to build the project on the GitHub repository page. So once all components are up, we can close the terminal and open the browser. Go to localhost :30,000 and log into the system with the default credentials, which are admin. We can change and should change the password later. So as you can see, the system has several sections that you can access through the side navigation bar. One of the first sections you would probably be interested in visiting is the policy section here. In this section you can create and edit policies. A policy is a set of configuration parameters that tells RoLa which checks should be performed and how. We have a default policy, but it is better to create a new one to be able to make modifications later. This policy can be edited. So we go to new policy, we put it in a name, and choose from which policy we want to take the base configuration, so we don't have to specify all parameters. Then here we have a list of all checks that RoLa Community Edition can perform. We can enable or disable each one of them, but also some of them have advanced settings that can be tweaked. For example, we can select the maximum number of retransmission admitted for a device. As we shall see later, if a device retransmission exceed this number, the system will alert us. After modifying the parameters, you click Save and the policy will be created. Later on, we can edit or delete any custom policy from here. After configuring the system, the second step is to connect RoLa to your LoRaWAN network. To achieve this, we need to create a new data source. The system already has a demo data source, but I will create another to show you the process, which is very simple. We have to first give it a name. And select the type of the LoRaWAN network. For now, the system supports CTN and chirp, but we are working to add support to more types. Then we have to select a policy. The system then will use this set of configuration parameters to analyze the messages from this data source. We can optionally add a description here in the second line. And finally, here we have to fill with our TTN password, user and gateway ID. Then we click on test connection to test if everything is okay. Save, and the data source is created. I didn't mention before, but from this screen you can also edit, delete, or disable each data source and see the logs. Now that we have our data source working, let's see the rest of the sections of the system. The first screen you will see when you log into the system is the dashboard. Here you have condensed information of all your networks. For example, the number of issues, alerts, devices, and messages sent. Here at the top, you have the number of data sources connected. And if you have more than one, you can filter using this select list. Finally, here at the bottom, you have the latest alert generated by the system. The second section is current issues. Here you have the issues and vulnerabilities that RoLa detects in your network. For example, as Matthias will show later, devices with weak keys or configured with activation by personalization between other types of problems. Here at the top, we have some pies that show us how many issues of each risk level we have, or we only have low risk vulnerabilities for now. How many issues of each type? We can see that the only type of issue is that some devices has a signal to noise ratio too low. How many issues on each data source, and the number of devices with issues. And here we have the complete list of issues. If we click in one of these issues, we get more information. The next section, alerts, is similar to the previous one. The difference between an issue and an alert is that the first one is more like a state of the device that is maintained over the time or until the administrator solves the problem, while an alert is a punctual event that probably needs the urgent attention of the network administrator. Here we also have some pies that show some stat that can be, and that also can be used for filtering. And we also have a filter by time here at the top, and well, some buttons to quick
quickly choose a period of time. For example, we can see the alerts of the last week or the last day. The fourth section is the inventory. This section objective is to have a real-time inventory of all your LoRaWAN devices. Here again we have some pies that can be used, that are used to show some stat and that can be used for filtering, for example, to see only devices of a specific vendor. Here we can set an importance to each device. For example, I can choose these three gateways and set an importance to high. So then I can go to Events Manager and choose that the system send an email to a specific direction only for high importance devices, but for alerts of high risk. We click Save. Here in the directory, we can also set labels to the devices to group them. For example, I can choose these 4 devices and assign a label. I will create a new label and set to this group of devices. And to this other group, I will assign another label. So then I can filter those devices clicking here in this bubble graph. If I click in the ID of a specific device or a gateway, for example this, another tab will be open with the 360 view of the device. On this screen, we have all the information related to one device. For example, we have some general information here, the status of the device, the name, the vendor, the application. We have a map that shows the approximate location of the device if the gateway that is connected to has a GPS. Then we have the issues detected on this device. We also have the alerts shown in this table and in this timeline. And finally, at the bottom, we have information related to the connection, as the frequency of messages, when was the last message you received, the signal strength, signal noise to ratio, the payload size of the messages, which gateways are listening to this device, and several counters for uplink messages, downlink, and lost messages. And we have also counted for retransmissions, join requests, and failed join requests that are join requests without showing accept. Here we have a graph with the signal to noise ratio and the signal strength over time. And that's all for the 360 view. The last section of the system is the network overview. This section is similar to the bottom part of the 360 view. It has a complete list of all the devices of the network and show information related to the connection. For example, when was the last message sent, the counter for uplink, downlink, and lost messages, the frequency of the time between messages, the signal strength and signal to noise ratio, the payload size, and the number of gateways that are listening to a specific device. Well, that's all. Now Matthias will show some use cases to the system and explain a little more about the alerts and issues that the system can detect.
Hello everyone, and thanks Chris for the presentation. My name is Matias Sequeira and I'm a security researcher, and back in the days I contributed to the LoRaWAN research for this very cool project. So now I'm gonna guide you through the many use cases we have prepared, and I hope you like them, and I hope you really understand the value of this very cool open source product. So we no further talk, we just go ahead with the use cases. So the first use case I prepared is the possibility, we'll see how to detect devices that are using the defaults or easy to guess or very like known app keys. So let's go to the product. First, we will see, let's go ahead, let's take a look at one of the alerts. So now I'm gonna filter by last month. Sorry, app key. So here we have 5 different devices that we were able, that we found the app key. So now let's take a look at this one. We have that this device with this identifier is using this app key. Here we have more information such as the gateway that that device is using and many other data. For example, here the tool is telling us that it was able to crack the app key using 2 different friend request messages, and I think that that's it. Another cool thing that I want to show is the possibility to provide the tool with the keys you wanna try. Let's here you can write your own keys and hit save, and the tool will start testing that key against all your devices that are detected in the platform. This way, you could, for instance, provide the, let's say, the default app key that that your devices came with, and that way you can make sure you aren't using the default app keys, or the engineers that installed these devices didn't or did change the app key. The next use case that I'll show is the possibility to detect duplicate sessions. To do so, we'll come back to alerts. We'll filter by last month and duplicate sessions here. And let's choose this one. And so here the alert is telling us that we had this device with this device address. Doesn't have like an identifier. I think that's because it's like an ABP device probably. So the alert is telling us that the last counter that was detected for that device was 644, but after that we received another message with the counter 15. This might tell us that there is a chance that a potential attacker is trying to inject valid data packets into our LoRaWAN server. And to do so, of course, the attacker needs to generate a valid pair of session keys. So this way we can have an idea of a potential attack or someone injecting fake data into our LoRaWAN server. The next use case that I'll show is the possibility to detect anomalies or problems in your LoRaWAN network. And this is done by using a couple of alerts that use artificial intelligence. So first, before showing the alert, I'll go to the policy, and I want to show you different parameters that we use to detect these kind of anomalies. So we have 2 different alerts. The first one detects anomalies in the shrine request messages, and specifically in the frequency of these shrine request messages. Here we can customize its value. For instance, we can change the sensitivity for that alert. We can increase or decrease the false positives. And also we have another alert for anomalies in data packets, this one. And here we have many other parameters, such as the strength of the signal, the size of the payload, the time difference between each packet, so and many other parameters that we can play with. So what this alert does is to kind of create a profile for each device, and it kind of sets, let's say, normal or standard values for each device. And whenever we have like a different value for those parameters, then the alert is flagged. So now I'll go to alerts, and I want to show you the anomalies. Let's filter by last month again. Anomalies. So we have this one with the strong request frequency. So we don't have much data here. We have that the time difference within each strong request was 532 seconds, but the most valuable information is here in the 360 view for devices. So here, for instance, we have that this device was trying to join, and we have 3 failed joins that where the device wasn't able to connect with the LoRaWAN server. Also here we see that this graph looks like kind of weird. This is the signal strength versus the signal noise ratio. And also we can see that this device is sharing the same device address with another device. And of course, we have this alert that we saw earlier with the anomaly. So by looking at this screen, we can tell that something weird is going on with that device, and we should review it. The other anomaly is with the data packets. Let's take a look at this one. This is the only one in the system. Let's go again to the 360 view. Okay, so this is interesting. Here we have that the system was able to crack the app key of the device. So this might tell us that someone is able to crack that same device, that same app key, and is able, of course, to inject valid data packets into our LoRaWAN network. Also, we can see that the connection isn't quite good for this device, and we have that now isn't transmitting data. Also, of course, we have this graph that looks even more weird than the previous one, and I think that's it. And the signal isn't very good. So I don't know. I think that we can think that this device got hacked or could be hacked, and something, I don't know. We have to investigate about this incident. So let's move on to the next alert. Also, with RoLa Guard, we can track both connections and disconnections for devices. Let's go to alerts. Let's pick this one, device connection lost. So here we have that this device with this identifier is kind of losing connection. Then we can go again to the 360 view, and we have we have like a bunch of alerts telling us that the device is losing connection and the signal to noise ratio is below the threshold. If we take a look at this graph as well, looks like very weird. So something really weird is going on with the signal. In fact, we have this very weak indicator here, and we have that this device is losing a lot of messages and is doing a couple of retransmissions. The next use case is that with RoLa we can detect devices that are trying to join our network. If we go to alerts, then we can take a look at it. It's filtered by last month. So by looking at this alert, this alert is telling us that there's a device that's sending us a join request, but our server isn't like replying with the join accept. So that device isn't able to join our LoRaWAN network. And this could be due to two things. One of them is a possible misconfiguration that we are missing, so that the device is having trouble to join the network. And the other indicator or the other potential cause could be that that device isn't part of our network. So that's fine. That device isn't meant to join our network, so that's cool. The next and the last use case is that I want to show you is the possibility to detect problems with the LoRa physical layer. And to do so, we can take a look at network overview. I'm gonna try to get a couple devices that are having kind of connection problems. Let's filter by signal strength. So, okay, let's take a look at this one. Okay, so we have the historical alerts. We can see that this device is having problems with the connection. It's losing connection pretty often. The graph again looks like really weird, and we have like a lot of lost messages, lost data packets. So this is telling us that there is a kind of problem with the connectivity with that device, and by knowing that, we should go and review and check if the device is out of range or whatever is going on with that device. And I think that that's it for today. And I want to thank you all for listening. And I want to remind you that since RoLa is an open source project, we welcome every kind of contribution with both security research or programming. So feel free to contact us. And also, I want to tell you that we'll be answering questions in the chat. Thank you all for listening, and bye.